Okay, class. Good afternoon to everyone. This is a presentation in engineering economy. So this covers simple interest and compound interest. Simple interest. Interest, it is the amount paid for the use of borrowed capital, or it is the money earned by an investment. So for example, if you invest money in a bank, of course, at the end of the year, the end of the month, or at the end of how many years, that investment will earn an interest. Okay. Simple interest. What is a simple interest? Simple interest, this is the type of interest that follows the principle of only the principal earns interest. Only the principal. Okay. How we are going to compute for the interest? Of course, interest is equals to the principal amount multiplied by the rate of interest and multiplied by the number of interest period. Okay. So the future amount can be computed as the principal amount plus the interest. Or simply, the future amount is equals to the present amount multiplied by 1 or the factor 1 plus I multiplied by N. Or simply, I is the simple interest earned, F is the future worth or the accumulated amount, P is the present worth or principal of investment, or investment rather, I is the simple interest rate in 1 year, and N is the number of years. Okay. So there are two kinds or two types of simple interest. One is the ordinary simple interest. Okay. So what is this ordinary simple interest? So this ordinary simple interest is computed based on 1 banker year, equivalent to 360 days. Okay. So the assumption, of course, of a banker in 1 year is only 360 days. So that is the denominator used in an ordinary simple interest in computing the rate of interest. Another kind of simple interest is the exact simple interest. So this exact simple interest, of course, is computed based on exact number of days in 1 year. Okay. So, 1 ordinary year, so meaning when I say ordinary year, it is not divisible by 4. Okay. That is equivalent to 365 days. But for a leap year, or it is divisible by 4, the equivalent is 366 days. So take note that if the year or the last 2 digit of the year is divisible by 4, that year is a leap year. Okay. So, Take note. If the kind of simple interest is not mentioned in the problem, then assume it is an ordinary simple interest, or 1 year is equivalent to 360 days. Okay? If exact simple interest, okay, an exact simple interest. So you see to it that all the days throughout the year will be computed. Okay, so take note that 30 days has September, April, June, and November. All the rest have 31 except February. For it has either 28 or 29. Okay? So let us consider an example in order for us to apply the basic formula or the basic principle in a simple interest. Okay, so let us take this example. If a man borrowed money from his girlfriend with simple interest rate of 12%, determine the present worth of 75,000, which is due at the end of 7 months. Okay? So, it was not mentioned in the problem if it is ordinary or an exact. So, if the problem runs that way, of course, the assumption is an ordinary simple interest. Okay? Where the assumption for the number of days in 1 year, for 1 year is 360 days. Okay, so let us now consider the problem. Okay. The future amount or the formula of the future amount is equals to P multiplied by 1 plus I multiplied by N. Okay. So, substituting the values, the future amount is 75,000. The present amount is unknown. And substituting to the formula, the 7 months. Okay, 1 plus 7 multiplied by 30. Since it is an ordinary simple interest, divided by 360 multiplied by the rate of interest of 12% or 0.12, the present amount now is equivalent to 70,093.05. Okay, so as simple as that. Okay, so let us take another example. So where in the first example, the unknown is the principal amount, where the future amount is already known. So by this time, in example 2, the parameter that we are going to compute is, of course, the interest. Okay. So let us now take this example. Daisy borrowed money from a certain financing firm. She received 1,842 from the firm and promised to pay 2,000 at the end of 10 months. What is the simple interest rate? Okay? So another as an ordinary simple interest, where the future amount and the present amount are already known. Okay? So, substituting now from the formula, F is equals to P multiplied by 1 plus N multiplied by I, where the future amount is 2,000, the present amount is 1,842, multiplied by 1 plus 10 months multiplied by 30 is 300 divided by 360 multiplied by I. And then, solving for I is 10.29%. Okay? Another example. So by this time, we are now going to compute for the future amount. Okay? Sample number 3. If 4,000 pesos is borrowed for 75 days at 6% per annum. Simple interest. How much will due at the end of 75 days? Okay? So, again, the formula for future amount is equals to P multiplied by 1 plus I, N. Okay? Or F is equals to the principal amount, which is 4,000, multiplied by the factor 1 plus 75 days over 360, multiplied by the rate of interest of 0.06 or 6%. So the future amount now is 4,133.33 pesos. Okay. So, very clear. Another example. So this is for an exact simple interest. Okay. Determine the accumulated amount using the exact simple interest on 1,000 pesos for the period from January 20, 1990 to November 28 of the same year at 15% interest rate. Okay? So, let us now compute the number of days. Okay. So, January is composed of 31 days. So, the loan starts at January 20. So, there is a remaining 11 days in January. So, February is 28. Since 1990 is not a leap year. So, that is why February is only 28 days. And then March is 31, April is 30, May is 31, June is 30, July is 31, August is 31, September is 30, and then October is 31, and then November is 20. Okay? 28 rather. Okay? So the total number of days is equivalent to 312 days. Okay? So getting now the future amount, that is the principal amount of 1,000 multiplied by 1 plus 312 over 365 multiplied by the rate of interest or interest period of 15%. So the future amount now is 1,128.22. Okay? So, again, last example. Okay. Determining the present amount. Okay, so we have already an example for an ordinary simple interest and another is for an exact simple interest. Okay? So this example now, Miss Malu Ang buys a Betamax set from a merchant who asked 10,785 at the end of 100 days. Cash in 100 days. Miss Ang wishes to pay immediately and the merchant offers to compute the cash price on the assumption that money is worth 11% simple interest. What is the cash price today? Okay? So when we say today, we are looking for the present amount. Okay? So again, F is equals to P multiplied by 1 plus I times N. Okay? So, F now is equivalent to 10,785 is equals to P multiplied by 1 plus 100 days over 360 multiplied by 11%. Okay, therefore, the value of the present amount now is 10,465.23. So I think it is now very clear to everybody. Okay? So next, we are going to discuss the compound interest. So, this compound interest is quite different from the previous kind of interest, which is the simple interest. So, this compound interest is the type of interest that follows the principal the principal interest on top of interest. So, both principal and interest earn interest. Okay, so this is different. Okay? So, let us derive an equation for this type of interest. Okay, so let us now consider a cash flow diagram. Okay? So, supposing arrow up is the present amount, and then we have the number of years from 0 to n, and then at the end of n years, we have an amount of f, or the future amount. Okay, so let us now tabulate. So to make it clear how the formula was, or how the formula is derived. Okay, so let us consider a tabulation. So the first column is the interest period. Okay? The second column is the principal at the beginning of the year. The third column is the interest earned during the year. And the last column is the amount at the end of the year. Okay? So, in interest period 1 or period 1, at the beginning, the principal is P, or designated as P. And of course, the interest, this P will be multiplied by the rate of interest I. So that is why, in the third column, we write PI. Okay? So, the amount, of course, at the end of the first year, of course, it is equivalent to the principal amount plus the rate of, or the interest earned at the end of the first year. So, that is why P plus PI can also be written as P, factoring out P, multiplied by 1 plus I. Okay. Next. During the second year, again, the principal amount during the second year is, of course, equal to the future amount during the first year, which is equal to P multiplied by 1 plus I. Okay. Again, at the end of the year, or the second year, this principal will earn an interest equivalent to P multiplied by 1 plus I multiplied by I. Okay, so that is why the future amount at the end of second year is now equal to P multiplied by 1 plus I raised to 2. Okay? So take note, this is the end of the second year. The exponent here is now 2. Okay. Let us again take another consideration in the third period. Okay. So the principal amount at the beginning of the third period is equal to the future amount at the end of the second period. And at the end of the third period, the principal amount will earn an interest equivalent to P multiplied by 1 plus I, square rather, excuse me, multiplied by I. Or the future amount now is equals to P multiplied by 1 plus I raised to 3. Okay. So, we will notice that whatever is the year, or yes, to be considered, at the end of that period, the exponent of the factor is equivalent to that period also. Okay, so that is why the future amount at the end of n years is equivalent also to P multiplied by 1 plus I raised to n. Okay? So, we have here the formula below that F is equals to P multiplied by 1 plus I raised to capital letter N. So, this capital letter N represents the number of years. Okay? Or simply P is equals to 1 plus, or P is equals to F multiplied by 1 plus I raised to negative N. Okay? Where I now is equals to IN over M. Okay, this M now is the number of compounding periods per year. Okay, so the number of compounding period, this is the sometimes compounded annually or yearly or per annum. Sometimes it is compounded quarterly, sometimes semi-annually, monthly, bi-monthly, or whatsoever. So that is why the number or N now can be defined as M, or the number of compounding per year multiplied by the number of years. Example, for example, in 1 year, and then it is compounded monthly, therefore, the number of interest period in 1 year is equivalent to 12 also. That is 1 multiplied by 12. Okay? So, for quarterly, of course, the number of interest period in 1 year is equivalent to 4. Okay? So, the future amount now for this type of interest, or for compound interest, is equals to F multiplied by, is equals to P multiplied by 1 plus IN over M raised to MN. So, where F is the future amount, P is the present worth or the present amount, IN is the interest rate per period, IN is the nominal rate of interest, M is the number of compounding periods in 1 year, or the number of payments in 1 year. N is the number of years, N is the total number of periods, and I plus, or 1 plus I raised to N. This is sometimes called the single payment compound amount factor, with a functional symbol of P over F at I% and in interest period. Okay? Okay. So, based on the tabulation above, the series of the future amount value for each year can be calculated using the principle of geometric progression. Okay, so we are now going to derive the formula for the future amount using the geometric series, okay, or geometric progression, where that geometric progression in algebra, that is an is equals to the a1 or the first term multiplied by the common ratio r raised to n minus 1. Okay? So, an is the future amount at the end of the nth year. A1 is the first term of the series. R is the common ratio of the second and the first term or the third and second. And n is the number of terms. Okay, so let us now consider the common ratio. Okay. So, during the second year, the future amount is equals to P multiplied by I plus or 1 plus I raised to 2 divided by P multiplied by 1 plus I. So, this is the future amount at the end of the first year. Okay, where the common ratio now is equals to 1 plus I. So, P is eliminated. 1 plus I is again eliminated. Okay, so the remaining is, of course, 1 plus I. Since 1 plus I at the numerator is in square form. Okay? So, the future amount now, En, is equals to P. P is, of course, the first term multiplied by 1 plus I multiplied by 1 plus I raised to n minus 1. Or simply, En is equals to F, or the future amount is equals to P multiplied by 1 plus I raised to n. So, here, 1 plus I multiplied by 1 plus I raised to n minus 1 is equals to 1 plus I raised to n. Okay, so we have two derivations for the future amount of a compound interest. Okay, for the compound interest. Okay, so let us now take example on this. Okay, let us consider this. Ana Bautista expects to receive 50,000 in 6 years. How much is that money worth now, considering interest at 6% compounded quarterly? Okay, so quarterly, meaning in 1 year, the number of interest period is 4. So, the total number of interest period for 6 years is equivalent to 24. Okay? So, getting now the value of P, 50,000 divided by 1 plus I, or the nominal rate is 6%, and then the number of compounding is 4, so that's why the nominal rate will be divided by 4, and then raised to 6 multiplied by 4, which is equivalent to 24. So, therefore, the present amount now is equivalent to 34,977.2. Okay? So, I think it is clear. So, let us again take another example. Sample number 2. So, what is the least number of years needed to triple a certain amount of money at 5% compounded annually? To triple, meaning will become 3 times the principal, the future amount. Okay, again, The formula is F equals to P multiplied by 1 plus I raised to N, where the future amount is equivalent to 3 times the present amount. Okay? So, 3P over P, so P will be cancelled out, is equals to 1.05 raised to N. Okay? So, the natural logarithm now of 3 divided by the natural logarithm of 1.05. Therefore, the number of years a money will be triple is equivalent, or at 5%, is 22.5 years. Okay? Another example. Sample number 3. Leonard invests 450,000 now. Given that the interest rate on the investment is 14.5% per year, compounded annually. What sum in pesos will be collected 8 years hence after the investment has been reduced? Okay? Again, formula is F is equals to P 1 plus I raised to N. Okay? That F is equals to 450,000, the principal amount, multiplied by 1 plus 145 or 14.5%, and then raised to 8. So the future amount now is 1,329,402.24. So, getting now the difference, okay, between the present or the future and the present amount. So, that is now 1,329,402 minus 450,000. Therefore, the difference or the interest earned equivalent to 879,402. Okay? So, lastly, sample number 4. Okay, so let us take this sample again. Exactly 140 years ago, my grandmother deposited 190 pesos in a large bank as part of a saving plan. She forgot all about the deposits, okay, or deposit rather, during her lifetime. 2 years ago, the bank notified my family that the account was worth 200,000 pesos. What is the effective annual interest rate in this situation? Okay? So again, the future amount is 200,000 and the amount invested or the principal amount is 190. Okay. The rate of interest now or the effective rate of interest is equals to 1 or 200,000 equals 190 multiplied by 1 plus I raised to N. So since it is 2 years ago, that 2 years will be deducted from 140 years. Or I now is equivalent to 5.172%. Okay. So that ends my presentation. Thank you.